morning, everyone. Obviously, there's an enormous amount of hype around blockchain and cryptocurrency in particular, but there's also a healthy amount of skepticism. And it feels very similar to the early days of the internet when we were sort of 8 or 10 years ahead of some of those services and products that we're very familiar with today, but also where there were concerns about it being a nefarious place for dark activities, and there were lots of problems with the technology. But for every problem that exists for a technology, there's an opportunity for new organizations to emerge, new business models to emerge, and I think it's feasible that we are on the next wave of technology, the next generation of the internet perhaps, if you think about the combination of nascent technologies such as blockchain, AI, and the Internet of Things. So it's against this backdrop that I wanted to consider what this might mean for the scholarly communication ecosystem and whether blockchain could be truly disruptive for our industry. So I'm just going to start off by talking about what blockchain is, look at a use case outside of our industry, and then have a look at some of the proof of concepts that are emerging within our ecosystem, and then just finish up with a few conclusions. So I thought I'd start by talking about what blockchain isn't, because there are a number of common misconceptions. So Bitcoin is obviously the first and most well-known implementation of blockchain, but it's a use case with blockchain as the underlying technology. Public blockchains are open source, they're accessible to all, and there's not one single entity in control. But it's also possible to have private blockchains which are run by organizations or consortia of organizations where permissions can be set about who can participate and how consensus is reached. In reality, most public blockchains are entirely traceable. It's possible to track what is being sent as well as the to and the from aspects of what's being sent. And companies which specialize in blockchain analytics have tools to track illicit transactions back to the source. So if anything, blockchain offers pseudonymity rather than anonymity. Many also believe that blockchain records can never be hacked or altered, but obviously no system is ever 100% secure. Any person or group within a public network is capable of gathering enough mining resources together to take control of the blockchain. So while this is unlikely, as they would require mining capacity greater than the rest of the network, it's theoretically possible, and this is where we're seeing 51% attacks. And we're also hearing about some of the cryptocurrency exchanges being hacked as well on a regular basis. So a number of misconceptions at this stage. So that's what blockchain isn't, but what is it? It's an innovation in value transfer that combines existing proven technologies, so the internet, cryptography, and an incentivization protocol. So it's a technology that allows peer-to-peer transactions to be recorded on a digital ledger across a network. Each node within a network holds a copy of the blockchain, so there are multiple copies of the blockchain, almost like thousands, millions of spreadsheets across the globe. It supports digital transactions without the need for a trusted third party. So if we're thinking about financial transactions, if I want to pay another party, typically I would put my trust in a bank or PayPal or something like Visa to ensure that they're verifying that I'm the sender and the money I'm sending is real. But in a decentralized blockchain environment, I'm putting my trust in the blockchain network. I'm putting my trust in cryptography and the consensus of the network. But it does mean that it reduces the need for that middleman of the bank, of Visa or PayPal. So potentially there's an opportunity to create some efficiencies, cut down on time, and potentially cut down on cost. So transactions are authorized by the network. There's no single official master copy of the database. It's distributed across the network. So if one of those disappears, there are plenty of other copies around the network, which obviously has implications for things like censorship and so on. And there's no centralized authority making decisions about that particular blockchain. So in very simple terms, how does it work? So there are 3 things within a block. There's data, and the type of data depends on the type of blockchain it is. There's a hash or a unique fingerprint, which identifies the block and all of its contents. And then there's the hash of the previous block. So it's essentially chaining that block to the chain. So If I change something within that block, the hash will change, so it's no longer the same block. So in this scenario, if I tampered with the second block here, the hash would change, which would mean that block 3 and all subsequent blocks would become invalid. So that's one of the security features, if you like, of blockchain, but that's not really enough to make it tamper-proof. The other aspect to blockchain is having a proof of work concept, for example, or a proof of stake. In a public blockchain, proof of work would typically take the form of miners working to solve a mathematical problem, and the first one who solves that problem is then rewarded. That block then is accepted by the network and becomes part of the chain. If that was rejected, then that block would be rejected by the whole of the network. So that's the sort of second security element. And then the third is that the blockchain is distributed. So the copy of the truth, if you like, is distributed across the network. So from a bird's eye view, blockchain is very similar to a lot of other things we're aware of, databases. And I think if we look at Wikipedia as an example, with a blockchain, people can write entries into a record of information. A community of users can control how that record of information is amended and updated. Likewise, Wikipedia isn't the result of a single publisher. No one person controls the information that we read on Wikipedia. But if we look into the differences between blockchain and something like Wikipedia, I think what's unique about it becomes a bit clearer. So if you're changing a Wikipedia entry, that's then stored on a central server. So when someone comes to the Wikipedia site, they'll get an updated version of the page that's coming from the central server. And that database remains under the control of Wikipedia administrators. So Wikipedia's digital backbone is very similar to the highly protected and centralized databases that are used by banks, governments, and publishers as well. The owners of those databases are responsible for management of updates, access, and protecting against cyber threats. But in a blockchain, the database is distributed. The digital backbone is fundamentally different. So every node in the network is verifying those new transactions, those changes, and they're reaching consensus, and they're updating the record independently. So there is no one master copy. There is no one entity who is controlling that particular database, that particular information. So in terms of the jargon around blockchain, I just thought I would just mention a few of these. dApps comes up a lot. A dApp is a decentralized application built on top of a peer-to-peer network, such as blockchain. There are also digital wallets, so that's a personal wallet for cryptocurrency. So if you want to use a cryptocurrency, you need to have a wallet, and that's a way of exchanging one cryptocurrency into another, or potentially exchanging cryptocurrency into a fiat currency, such as dollars, pounds, or euros. There are also smart contracts, which are simple programs which are stored on the blockchain. They're self-executing and they're immutable. And this is where some of the interesting use cases are coming around at the moment. So there's one that a French airline has recently been experimented with called Fizzy. So this is an app where they're looking at taking travel insurance onto the blockchain. So the idea is they're making it easier to give you compensation if your flight's delayed. And I think we all know how difficult that normally is to sort out if we even bother. So what happens here, there's a smart contract on the app. So if the plane's 2 hours late, that's the trigger. It will then generate a message to the customer to say, here are your compensation options. You choose your compensation option, and that then gets paid into your bank account. So it's making that automated, it's making it much more efficient, a much easier and more pleasant customer experience. So that's an example of a smart contract. And the other area to flag up is the initial coin offering. So very similar to the stock market, this is a way of raising funds but using cryptocurrency. So a lot of the blockchain startups are using this as a way of generating funds, but it can also be a way of releasing a new cryptocurrency and offering early options to investors. So what are the benefits of blockchain? Transparency is one of the key ones. Ease of sharing and visibility are essential features of the blockchain. And I think it's the absence of this often which is driving the use cases that we're seeing, particularly within financial services. Each blockchain is timestamped, the ledger can't be altered, so the immutability aspect of blockchain is attractive to many parties who are looking at using this technology. The immutability of blockchain also makes it nearly impossible for changes to be made once established, which increases confidence in data integrity and reduces fraud. It's also the decentralization aspect, and I think this is one of the key differentiators for blockchain. So obviously that ensures that there are multiple copies, protects against data loss, but I think what's really interesting here is the protection against censorship. So, for example, when we've seen in the publishing world that certain contents had to be removed in mainland China, if that content existed on a blockchain, it would be impossible to remove that content because there isn't one single entity in control of it. If you remove one copy, it exists in multiple places around the globe. Privacy, I think, is another interesting area where blockchain could add some value and offers an opportunity for individuals to take greater control of their personal data. So if you could imagine a scenario if digital identity was controlled on the blockchain, it would give you the option to, for example, if you were looking on Compare the Market for your car insurance, you could temporarily release a subset of your personal information to that service so they can just take what they need in order to provide you quotes on car insurance. You can then rescind that information back from that service so they no longer hold it. So it gives you greater control over your personal information. I think it's interesting from a GDPR perspective, but it also perhaps opens up some opportunities around new business models where individuals could potentially monetize their data if they want to, rather than large organizations like Facebook and so on. But what are the issues? As we know, there are lots of downsides to blockchain, and there are a number of limitations. And I think the big one really is performance and scalability. It's always going to be slower than a normal database. So as well as undertaking all of the regular processes that a database would undertake when a new block gets added, it has a number of extra processes. So this is going to add extra time. And also we've seen in terms of scalability, if you look at the cryptocurrencies, they're only seeing 15 transactions per second, whereas something like MasterCard would see 45,000 transactions per second. So in order for some of these services to really be competitive, that scalability and performance issue needs to be resolved. Obviously, a blockchain network grows at an unprecedented pace. It consumes heavy resources. So there's an environmental impact to consider there as well as the cost. As we've seen, there are some security vulnerabilities that need to be resolved. And there's also the human element. The data that's stored on blockchain is not inherently trustworthy. It's only as good as the data that a human has added there. Immutability is not always a good thing. Obviously, errors can be made. If it can't be changed, those errors are out there in perpetuity. And at this stage in the sort of early life cycle of blockchain, there's a lack of standardization, there's a lack of regulation, particularly around the ICOs, which is causing concern in some countries. I know in China they were thinking about banning ICOs, but they've sort of since relented. So there's all of that stuff to work out. And there's a limited programming ecosystem, so if you do want to experiment, obviously it's early days, so that infrastructure and the broader ecosystem has yet to grow. So in terms of the use cases that we're seeing at the moment, obviously financial services, the insurance industry seem to be leading the way there. There are lots of interesting use cases, I think, particularly in certain countries where there's a high proportion of unbanked people. So if you think about something like Western Union money transfers between countries, in that scenario, the money has to pass through several institutions, it can take a number of days, and there are commission charges there. Whereas if that was potentially on a blockchain, you cut out the middleman, it means that that money can transfer much more quickly, there isn't the same commission attached with it. So there are sort of potentials to have some efficiencies and cost savings within the financial industry. I've mentioned digital identity. I don't think there are any big projects in this area right now, but for me, this is a really interesting area, and perhaps, sort of as we're thinking about things within our industry, it raises some different questions. Government services is another interesting one. Estonia and I believe Dubai are looking at bringing in digital passports on the blockchain, but there's also the potential to use it for voting in terms of that sort of immutability of the technology and the transparency associated with that, and avoiding some of those sort of corruption issues that we see sometimes. Charities is another area where this has potential to be really, really useful. So if there's a natural disaster and a lot of documentation, administration has sort of disappeared, if information is stored on a blockchain in terms of, what people own in terms of property, how aid can be transported to the right people locally on the ground who need it, rather than going through some of these bureaucratic processes, it's a way of sort of maybe transporting aid in a more efficient way. Supply chain is another area where there's a lot of investment going in. So, for example, there's talk about sort of recording the provenance, particularly of food products and pharmaceutical products, at the point of creation through to the point of sale. So there was one example where a supply chain implementation was combined with Internet of Things, where it was recording where milk came from, what date it left the farm, but also then within the lorry itself used Internet of Things technology, so it's constantly monitoring the temperature within individual milk containers. So when it gets to its end point, if there's a problem with that milk, people already know before it's got there, because that information has been recorded, has come through on the blockchain, and they can actually trace where the problems happen. So I think there are lots of use cases in the supply chain side of things, and also a sort of tie-up with the Internet of Things, where there are going to be, so many transactions that need to be handled. So looking more broadly then, Gartner's forecasting that blockchain will generate annual business value of over $3 trillion by 2030, and that 10 to 20% of global economic infrastructure will be running on blockchain-based systems. So that's the forecast, and they're also suggesting that by 2020, there'll be 20 billion connected devices via the Internet of Things. And I think this is again where perhaps blockchain will come more to the fore as a way of managing those transactions, as being the sort of Internet of value, if you like. And in terms of investments, the 50 largest public companies are investing in blockchain. The number one is a Chinese bank, but in the top 10 you've also got others that you would expect. So Apple and Facebook, I believe, are in the top 10. Looking at different ways of using blockchain, but also varying degrees of openness of what they're doing there. Obviously the financial institutions, organisations like Shell, Nestle and Walmart from a supply chain perspective, but also the pharmaceutical companies. So, moving on to one of the use cases that's out there at the moment. I should say this is still at the sort of beta stage. It's still a prototype. But this is Mycella. It's a project that reimagines the music industry. So it's looking at how blockchain could be used to solve some of these long-standing issues within the music industry, providing artists with the necessary tools to manage their career. So it's founded by Imogen Heap, who's a Grammy award-winning artist. I believe she wrote some of the music for Harry Potter the musical. And her vision is to empower a fair, sustainable and vibrant music ecosystem. So the crux of the product really is to create an open database of metadata around music and associated works and the artists and all of the other people who are involved in music creation, and combine that with the creative passport. So that's a digital container holding profile information, but also acknowledgements, payment mechanisms and so on. So this is set up on a blockchain, and there are smart contracts that allow for quick and easy payments. So this allows fans to come in and buy tracks that Imogen Heap has released through the blockchain, so she's doing this already. But it also means if someone wanted to use one of her songs, say in an advert or in a movie, the smart contract's already set up so they can come directly into the blockchain, they can clear the rights to use that music, and the payment happens automatically. Taking that a step forward, what she's also done within the smart contract is define what percentage she gets and what percentage other people within the team receive. So the sound engineers and sort of the multiples of other people involved in actually creating a track. So when some revenue comes through, when a royalty comes through, that automatically gets split between the relevant parties and paid into their bank accounts. So the service is going to be free to music makers and fans, but there's going to be a subscription-based service for businesses. So anyone who wanted to use that metadata and build a DApp on top of it, there would be a subscription fee associated with that. So it's currently in alpha test. So it'll be interesting to see whether this takes off. And I think obviously there's potential to disrupt the content intermediaries in this scenario, potentially reduce the price to consumers and also open up some different business models. But it's reliant on enough people using these types of services. So I think what might push the boundary here is if some of the major artists decide that they want to sort of break free of the labels, because this cuts out the need for a label. If you want to break free of that and use this, that may push the boundary. But also if one of the services such as Spotify or Amazon or Netflix decided to implement their own private blockchain, again, that sort of may push the use case, but obviously would allow those content intermediaries to sort of protect and retain their position within the ecosystem. I should say, and this project's not for profit. So turning now to the scholarly communications industry, where there are a number of blockchain initiatives emerging, and they all seem to have this common goal of trying to solve the challenges associated with transparency, evaluation, reputation, and reward within our ecosystem. So I just want to share a few of the initiatives I've been looking at. Skip through that. Scienceroot is one. This is founded by a physicist and an engineer, and they launched the concept in 2017, and they're undergoing ICO funding rounds at the moment, and they'll be doing that over a 2-year period. So the vision for this is that it will be a blockchain-based scientific ecosystem that integrates a social network, a funding platform, a decentralized publishing framework for journals, and that's underpinned by its own cryptocurrency. So they have a number of different sort of parts to this ecosystem. So there'll be a Scienceroot marketplace, which will be a decentralized marketplace where scientists and practitioners can come and make their services and knowledge available in return for tokens, in return for cryptocurrency. They have a repositories concept that will bring together all the outputs of the scientific process. So they're looking at manuscripts, they're looking at preprints, they're looking at grey literature, data, the whole gamut of the different content types that we see. So bring that together in one place on the blockchain. Interestingly, they're also talking about having a Scienceroot journal, which I thought, given that's the traditional container, it's interesting that they're still talking about going down that route and having Scienceroot medicine, Scienceroot biology. They're also talking about creating a funding and jobs platform so that you can bring funders together with researchers and create more of that sort of community space alongside the content side of things. There'll also be a Scienceroot fund, which will be a pool of tokens, which can be used as funding capital for scientific projects, grants, and other rewards within that system. So the idea is that the cryptocurrency, the token in this space, will incentivize a lot of the behavior. So it will be possible to give authors tokens for publishing their article or adding other content to the space. Reviewers could be rewarded with tokens. But also, interestingly, researchers could get funding via cryptocurrency through these sorts of networks. So that's Scienceroot. They've got an early app that's available if you want to take a look there. The next one is Pluto, and their first release is Synapse, which is more of an academic search engine. But to take a step back and give you a bit of context, they're based in Korea. They're a not-for-profit founded by academics, and they have a mission very similar to Scienceroot of creating a decentralized scholarly communications platform, and they plan to tackle this by, again, using cryptocurrency to drive a lot of the ecosystem. So in this scenario, authors will upload their paper to the platform, and they'll pay a reward token instead of an APC. Other researchers will then evaluate that paper in return for tokens. The evaluation records, or peer review reports as we would know them, are then published when the audit process is complete, and reviewers then receive compensation based on the quality of their evaluation. And they're talking about putting some algorithms in place to determine the quality of a particular peer review. The content's then distributed to the network for public comment. So Blockchain was selected as the backbone here because they felt the technology fitted with their core goals, that it's transparent, it's immutable, and it's managed by a peer-to-peer network. It's putting control back with the scholarly community. They also raised concerns about censorship, so again, this was another reason for using blockchain technology here. So it's very early stage, the search engine's there, and I know it's pulling in content and metadata from some publishers already, so it might be interesting to hear later on if anyone's got direct experience of that service. A slightly different vein, there's Scientific Coin, and this is a blockchain-based crowdfunding platform. So this is all about connecting researchers with funders, so providing alternative opportunities for research projects to gain funding through cryptocurrency, and they're also supporting other crowdfunding opportunities there. And the last one is Orvium, and their sort of tagline is Science Revolution in the Blockchain. And this has been founded by ex-CERN and NASA scientists, and the business model, again, is based on cryptocurrency. They have the ORV token. So you can see there are a number of similarities across these different initiatives. And what they see as important about blockchain and their service is that authors, by publishing their papers on the blockchain, gain instantaneous proof of existence. They get their timestamp record. This is my concept. This belongs to me. That there's continuous and transparent peer review, that the ecosystem supports all of the grey literature, all of the supplementary data, as well as the papers themselves. And they're also talking about integration with big data, so they want to look at alternative metrics. So again, sort of pushing back against the impact factor and using some of these technologies within a different space. So in terms of, I should just say this is what Orvium have released so far. Again, it's more of a search interface, but they're going to be adding more. I think 2019 Q4 is when they're expecting to have something that's sort of a bit beyond MVP. Don't want to say too much about Katalysis because that's going to be covered in the panel this afternoon, but I just wanted to flag it as another initiative in our space, but focus more specifically on the peer review side of things. So in terms of whether blockchain represents a revolution for the scholarly publishing industry or whether it's a distraction and a rabbit hole that we're all going to end up in, is an interesting question. I think I would emphasize that blockchain is a nascent technology. We're in the really, really early stages here, and predicting the next generation of the internet is a guessing game. However, I do continue to draw comparisons with those early days of the internet and expect a number of the problems that we've talked about associated with blockchain to be resolved over the coming years. So the blockchain and the headaches that we know about today probably will look quite different in 5-10 years' time. But is blockchain a panacea for all of these problems? No, absolutely not. I think it's still very much about choosing the right tool for the right job. And I just see blockchain as potentially another tool to consider when we're making decisions about the right technologies. I think the interplay between AI, the Internet of Things, and blockchain is interesting, and there's likely to be many more use cases coming out in that space. I think from a privacy and a personal data perspective, again, there's mileage there, and looking at whether blockchain is the right technology to resolve some of the issues we have there. And I think in the face of things like Facebook's woes with things like Cambridge Analytica, the question of digital ID is becoming ever more pressing. Thinking about those initiatives in the scholarly space, decentralization, transparency, efficiency, creation of new ecosystems that reward and look at reputation in different ways. They were all common threads coming through in those initiatives. So while blockchain may not prove to be the sort of killer technology within our industry, I think some of these common themes and strategic questions are really important to consider and look at sort of what our future ecosystem might look like. Are publishers at risk of being disintermediated? What alternative role is there for publishers in the ecosystems that we've looked at? Are there opportunities to layer on different services, play a slightly different role in that sort of ecosystem? Or is there an opportunity to take the position that some of the banks have taken, for example, of creating a consortia of publishers to build a private blockchain that then gives greater control over the infrastructure, but still implements the same sort of ecosystem? And I think, again, that's an interesting question in terms of, is it sustainable for us all to be investing in silos of infrastructure infrastructure, and sort of thinking about ways that we can move towards more common infrastructure goals. So ultimately, if it doesn't result in a revolution for our industry, it's raising some interesting questions, and I think for that reason, it's a catalyst for change. So thank you. Any questions?
Thanks very much, that was fascinating. You mentioned how if you can control a majority of the nodes on a network, it's no longer really secure. Does that mean if you're coming out with a new consumer product, like some of the things you've shown us, there's a sort of minimum critical mass to get over in terms of take-up before the security gets on its feet? And if so, how does a business handle that with a new product that's built on the blockchain?
Yeah, I think it's really interesting. Obviously, it depends whether it's public or private. If it's public, that's obviously the big question. Yeah, if you're Google. I don't know is the honest answer of what the critical mass would be, and I don't think there's been enough activity to sort of really prove what the tolerance level would be there, but obviously that's going to be a huge risk factor and probably a barrier for entry for a lot of companies. So I think it needs to go through a lot more experimentation and failures, if you like, before that question can be properly answered.
Thank you. One question before the panel, maybe even. Basically following up on your question, so what always puzzles me is that decentralization and efficiency are one of the two benefits which are advocated or hyped when people talk about blockchain. But if you look at the most prominent example of blockchain, which is Bitcoin, it's not efficient. And I don't think it's really decentralized anymore. I mean, there are a very small number of nodes that actually control this network now. The very few miners that have the computing power to mine new coins. And to me, that's a central problem that has not been addressed. And a lot of the use cases I see are private blockchains. Mm-hmm. And there I really question where's the difference to a distributed database?
Yeah, I mean, I think obviously there are a lot of flaws within Bitcoin, but already I think there are 90 cryptocurrencies now, and I think already with the newer cryptocurrencies, they're starting to solve some of the issues that Bitcoin has had. So I think it's that sort of incremental improvements. But yes, I think there's always that question of, you know, in terms of the use case, what does blockchain offer that a database wouldn't offer? And that's always got to be the question right now, to make sure it's not just a sort of, we're using this because it's new.
I'm Joris from 67 Bricks. The platforms you mentioned, Scienceroot and Synapse, I haven't looked at them, but they look like they kind of log the user in. And in a way, they've got the whole ecosystem. And I was wondering, how interoperable are they? Can they talk to each other? Can they talk to non-systems based on other technologies than blockchain?
Mm-hmm. But I think some of the initiatives are integrating with things like ORCID. I'm not sure that they're integrating with Crossref, but certainly there are the sort of integration points. I think one of them is integrating with artifacts. So, you know, again, early stages, but there certainly are opportunities to integrate with, you know, standard infrastructure within our industry and other things as needed. Does that answer?
Yeah, thank you.
Yeah. I think blockchain as a way of having an alternative currency is quite an ingenious thing. I've always been really impressed with the design of that. That there have been a lot of alternative currencies, and you know, we've had things like let schemes and stuff in the past that have alternative currencies, i.e. not controlled by a centralised bank and all of this sort of thing. The problem is it's always, how easy is it for me to go and buy a sack of potatoes with this currency? And you have all these different people with their private blockchains and private currencies and the 80 cryptocurrencies, but I can't go down the market and buy some potatoes. And I think that's the critical problem, and that's generally why you need a centralised national bank that guarantees a currency. I'm not quite... Do you think that, like if I've got these ovniums or whatever, I've got some ovniums over here and I've got some bits of this and a bit of that and a Bitcoin and half a, I don't know what, do you think that's going to, where's that going to go to? I'm sorry, that's not a very well-founded question, but
no, I know exactly
I've got some
what you mean.
confusion in my head around that.
I think the that challenge, what would be needed there is a sort of ubiquity of the digital wallet. So if you like, that's the sort of conversion house. So if there were apps that everyone had on their phone, and that included their digital wallet, it would mean you could, I must stop waving my arms around, it would mean that you could use different cryptocurrencies, you could use pounds as well, and that would all travel through the digital wallet. So I think, in the future, that potentially may be a way around it, but it would rely on that being an accepted method of the receiver of that payment to be able to accept payment in that way. And obviously then that would bring greater risks in terms of, exchange rates and all those sorts of things. So it's an interesting area. Thank you. I think that's